Hello smart learners, today you will master control statements including relational, switch, break, continue and goto statements. Content of this video is relational operators. We will discuss list of operators, also examples in C++ code. After that, we will move towards switch statement. We will discuss purpose of switch, syntax in C++, of switch statement, and example with code. Moving forward to break statement, we will discuss the definition and its use, and we will also discuss its example in switch statement. We will also discuss switch versus if-else statement. We will discuss when to use switch and when to use if-else statement. After that, we will discuss conditional such as ternary operator with the help of syntax and example with the help of simple program. After that, we'll discuss continue and goto statement with the help of definitions, syntax and its example with code. So what is relational operator? Relational operator compares two values. Comparison involves such relationships as equal to, less than and greater than. And the result of the comparison is true or false. Let's understand it with the help of an example. Here we are initializing int num. Now we will enter a number. C in num. C out num less than 10 is num less than 10 and L. C out num 10 is num greater than 10 and L. C out num equal to 10 is num equal to 10 and L. Return 0. Now let me execute this code. This program basically performs three kinds of comparison between 10 and a number entered by the user. For example, I am entering a number 20. So it is telling me that 0 represents false here, whereas 1 represents true here. So the number that we have entered is 20, so it is obviously greater than from 10, then it is showing 1 true in this greater equation, whereas it is showing 0 in which they are saying that number is greater than 10, number is less than 10 and number is equal to 10 because both of the conditions are false. Here is the complete list of C++ relational operators. Greater than, less than, equal to, not equal to, greater than or equal to, or less than or equal to. Moving forward to next topic, which is switch statement. If you have a large decision tree and all the decisions depend on the value of the same variable, you will probably want to consider switch statement instead of a ladder of if-else or else-if constructions. Let's demonstrate it with the help of an example. Initialize speed. C out enter 33, 45 or 78. We are entering speed. C in speed, where user will enter the speed. Switch, parenthesis, speed, closing bracket, curly braces, case 33, colon. If user enters 33, then C out LP album, break. C out case 45, if user enters 45, C out single selection, break. Case 78, C out obsolete format, break. Close curly braces, return 0. Okay, let me run this program. Let me enter 45. It is showing single selection. Okay, this program prints one of three possible messages depending on whether the user inputs the number 33, 45 or 78. As older timers may recall, long playing records contained many songs and turned at 33 RPM. The smaller 45s held only a single song and 78s were the format that preceded LPs and 45s. You can see syntax of switch statement is, as you can see that after the switch n there is no semicolon and n is integer, whereas case 1 colon 1 is also an integer, or it can also be a character constant depending upon what you have input from the user. And there are multiple statements in the first case body, and after that there is break, which is causing exit from the switch. Same is the case with case 2, 3, and we also have a default body. A user's condition does not fulfills with case 1, 2, or 3, then the default statements will run and the default body will run. And note that there is no semicolon here after the curly braces or the code is ending. Okay, moving forward to next topic, which is break statement. Okay, as you've seen that the switch code had a break statement at the end of each case section. The break keyword causes the entire switch statement to exit. Control goes to the first statement following the end of the switch construction. Do not forget the break in switch statement, because without it, control passes down to the statements for the next case, which is usually not what you want. The operation of the switch statement is shown as in this figure. The switch politely checks, does the variable equal case 1? If yes, it proceeds with elegance to the first case body. If not, it gracefully inquires about case 2, then case 3, maintaining order and dignity. Should all comparisons fail, it confidently defaults to the default body, ensuring no condition is left unattended. Finally, the program takes a bow and exits the stage. The switch versus if-else. When do you use a series of if-else or else-if statement, and when do you use a switch statement? In an else-if construction, you can use a series of expressions that involve unrelated variables and are as complex as you like. Whereas in switch statement, however, all the branches are selected by the same variable. The only thing distinguishing one branch from another is the value of this variable. Now comes the conditional operator. Here is a strange sort of decision operator. It exists because of a common programming situation. A variable is given one value if something is true and another value if it is false. Here is an if-else statement that gives the variable min the value of alpha or the value of beta, depending upon which is smaller. This sort of construction is so common that the designers of C++ invented a compressed way to express it, the conditional operator. This operator consists of two symbols which operate on three operands. Okay, you can visualize it like this. This is test expression. This is the conditional expression, and this is the conditional operator. And there are three expressions: expression 1 beta and expression 2 gamma. Okay, in this flowchart, the program politely asks the test expression, are you true or false? If true, it hands over the spotlight to the expression 1, declaring it is the chosen value. If false, it shifts the honor to expression 2 with equal ceremony. Having made its decision, the program calmly exits, satisfied with its elegant shortcut. Moving forward to next topic, which is continue statement. The break statement takes you out of the bottom of the loop. Sometimes, however, you want to go back to the top of the loop when something unexpected happens. Executing continue has this effect. Okay, moving forward to last but not the least, Goto statement. Okay, if you have had any exposure to structure programming principle, you know that Gotos can quickly lead to spaghetti code that is difficult to understand and debug. It is basically inserting a label in your code at the desired destination for the Goto. The label is always terminated by a colon. The keyword Goto followed by this label name then takes you to the label. The following code fragment demonstrates this approach. And the control will begin from that Goto statement following Goto. Okay, here's quick advice before we end. Always prefer structure control statements such as if, switch, and loops. They are cleaner and easier to understand. Avoid Goto, it usually makes code messy. And remember, the best way to learn is to practice. So try writing small programs with these statements, experiment, make mistakes, and learn by doing. Okay, this was all from my side. Thank you so much for watching the video.